11th sum is integration of 0 to pi by 4 1 by cos cube x into root of 2 sin x 2 sin 2x. Multiplying dividing by cos, so cos to the power 4 will become secant to the power 4x, and splitting the denominator of sin 2x as 2 sin x cos x, it becomes 4 sin x cos x, and the cos x on the numerator can cancel and taken to the root by cos square x, so it will become like this, and tan x is t, secant square x dx will become dt. Change the limits, so get the answer. Next sum is integration of 0 to a x to the power 4 by root of a square minus x square, where I write x is equal to a sin theta, dx is equal to a cos theta, and substituting, and a square minus a square sin square theta is just a cos theta. The a cos theta directly gets cancelled, so the question becomes a to the power 4 sin to the power 4 d theta, which is 1 minus cos double angle by 2 the whole square. The rest of it is a known story. You can substitute the limits and get your answer. Then is 1 plus sin x plus cos x into dx. Write sin x as 2 tan x by 2 by 1 plus tan square x by 2, and cos x as 1 minus tan square x by 2 by 1 plus tan square x by 2. Take LCM, and then assuming tan x by 2 as t, secant square x by 2 into 1 by 2 into dx will become dt, so 2 to get cancelled, log t, which is log of 1 plus tan x by 2, but I have written something else as answer there. Just check out, okay. So let's go to 14th question. Yeah, this is a very difficult question, where it's x square by x sin x plus cos x the whole square. This sum, unless you have memorized how to do, you can't do, because you're going to do integration by parts, wherein you have to write x square as x and x and this x, you should write an x here and an x here, the x square, and multiply and divide by cos x and cos x in such a way that you split it like this, and you assume this as t, the denominator here, and differentiate it, you get x cos x dx as itself a dt. So I am writing like this and doing integration by parts and solving it, I get this answer, okay. So then 15th question is this, wherein I decide to split it up as x by and a mod x plus, just split this up into two terms, so in such a way that this is f of minus x in this term becomes minus of f of x, so entire answer itself becomes 0 for this, whereas here it will not be so. So the question only boils down to the right hand side. Now I have to rewrite the question, okay. So let's rewrite the question to be minus 1 to 1 mod x plus 1 by x square plus 2 mod x plus 1 into dx. So now from minus 1 to 0 it will be minus x plus 1 by x square minus 2x plus 1, because mod x will be negative dx, and plus 0 to 1 it will be x plus 1 by x square plus 2x plus 1. So here, okay, this itself is x minus 1 the whole square. So if you take the negative out here, it will become x minus 1, so this and this get cancelled with the minus 1 to 0, limits will be minus 1 to 0, and for this it will be x plus 1 the whole square in the denominator, this and the power get cancelled, so then it will be log answers with this the negative sign here, so it's minus log of mod of x minus 1 integrated from minus 1 to 0 plus a log of mod of x plus 1 integrated from 0 to 1. So we'll substitute the limits, minus log of log 1 minus log of minus 1 is minus 2, log of minus 2, yeah, log, okay, when you substitute upper limit it's log of minus 1 with a mod, right? So this is also with a mod, so it will become 2. So then there is a bracket here because minus is common, so it's log 2 minus log 1, and log 1 is anyway 0, so log 2 is this, and what about this? This will be log 1, this will be log 2 if you substitute upper limit, log 1, so log 2 plus log 2 is 2 log 2, no, but answer is supposed to be 0, so what is the mistake? um, minus log of mod of x minus 1, minus 1 to 0. So this minus is common outside, and when you substitute 0, it will become log of minus 1 is become 1, minus a log of minus 1 which is log of minus 2, which is log 2, which is log 1 by 2. Okay, or log 1 is 0, so plus log 2 plus log 2, 2 log 2. Why have I written like this here? Let's figure this out. Plus log of mod of x plus 1. Okay, the limit is from here, it's minus 1 to 0. Do you know that the limits can be changed? If you're going to change this to plus, if you want to change, you can change this plus and write it as 0 to minus 1 also. If you want, you can do that. Okay, let me redo the calculation and see if I'm getting that as the answer or something wrong with the answers that I've written. So log of minus 1, so a log of minus 2 with a mod, and log of 0 minus 1 is just log 1, which is 0, so log of minus 2 is log 2. So you still have this with a plus, you still have a log 2. You still have a log 2, and a log 2 plus log 2 gives log 2 square, which is 2 log 2. Guys, can you check this answer, whether you're getting 0 or you're getting a log 2? Just check out, okay? So, and let me know, okay? So, let's go to the next question, which is the 16th question. 1 minus sin x by sin x into 1 plus sin x, okay, into dx. You know what I can do? I can 1 plus sin x minus 2 sin x by a sin x into 1 plus sin x by a sin x into 1 plus sin x. If I do this 1 plus sin x, will get cancelled. This itself is cosecant x, which is direct integration. By sin x and sin x get cancelled. It's 1 by 1 plus sin x, which can be rationalized, and rest of it is known, sorry, log of mod of cosecant x minus cot x, and this will become minus 2 into, you have to rationalize it, and 1 by 1 plus sin x when rationalized will be 1 minus sin x by 1 minus sin x, and minus 2 into 1 minus sin square x, which is cos square x by 1 minus sin x. Splitting it up, it will be minus 2 into integration of secant square x minus integration of secant x tan x, with the minus 2 being common, and this itself is minus 2 into tan x minus, this is just secant x, and so this is log of mod of cosecant x minus cot x, and yeah, and just take it in and you get the answer. Okay, so plus c. Let's go to the next question, which is the 17th one, which is 0 to 1 cot inverse of 1 minus x plus x square into dx. So this can be written as tan inverse of 1 by 1 minus x plus x square into dx, 0 to 1. This can again be written as 0 to 1 tan inverse of 1 by 1 minus x into 1 minus x dx. So x plus 1 minus x, you know, this I'm trying to split it up like that. So then I can write 1 as x plus 1 minus x, adding and subtracting an x and minus x. So it will become 1 minus x into 1 minus x, which resembles x minus y by with the 1 I've added x and subtracted x. So this is x plus y by 1 minus xy, which is tan inverse of x plus tan inverse of y, which is tan inverse of x plus tan inverse of 1 minus x, with an integration 0 to 1 dx in both the places. Only in one of it you substitute f of a minus x, f of x as f of a minus x. So 0 to 1 tan inverse of 1 minus x. So when you open it, it will become tan inverse of 1 and 1 get cancelled, tan inverse of x plus tan inverse of x, unless in a book sum, the last sum in miscellaneous where it will get cancelled, that was the question was in terms of tan inverse. Here the question is in terms of cot inverse. So it will become 2 tan inverse of x, 0 to 1. because this is simply tan inverse of x only. So then now you can do into 1 and do integration by parts. I late. So then tan inverse of x into x minus integration of 1 by 1 plus x square into x into dx. Now this is like t and dt, right? 1 plus x square as t, 2x into dx will become dt. You have a x dx, so dt by 2, 1 by 2 into dt by t, and this is 2 into x into tan inverse of x. So this 2 into x into tan inverse of x minus 1 by 2 into log t, which is log of mod of 1 plus x square. And whatever is your answer, just check out. Oh, is there a limits? Oh, 0 to 1. So then the wherever I've substituted, till here there's no substitution. Here is where I've substituted. No, I just did integration by parts. Oh yeah, here it is. The substitution part is here. It was from 0 to 1. So if 0, it's just 1, and 1 it gets to 2, is it? 0 to 1. If x is 0, t is 1. X is 0 to 1. T is 2. So only in this part, you don't have to go back and write, you can substitute. So it's 1 by t, which is log t, 1 by 2 into log t with 1 to 2. So here also it is from 0 to 1. So substituting, it's 1 into tan inverse of 1, which is pi by 4. That's sorted. Minus 1 by 2 into log 2, minus log 1 anyway is 0. So if you bring the 2 inside, it will be pi by 2 minus log 2. Yeah, and that gets you the answer. So let's go to 18th question. Is integration of root x by root of a cube minus x cube into dx. And as soon as I see a root x, I know x to the power 3 by 2 is t. 3 by 2 into x to the power 3 by 2 minus 1, which is 3 by 2 into x to the power 1 by 2 into dx will become dt. So that's such a way that I'll get this to be 2 by 2 third, 2 by 3 dt by, let it be, it is actually going to be written as x to the power 1 by 2 by a to the power 3 by 2 the whole square. Okay, doesn't matter, the 2 and 2 get cancelled. So x to the power 3 by 2 the whole square. So changing the question around like this. So then it will become a to the power 3 by 2 the whole square minus this itself is t square, and there's no root or anything there, right? Yeah. So 2 by 3 into root of a square minus x square, which is log of 1 by 2a. 1 by 2 into a to the power 3 by 2 into log of mod of a plus x by a minus x. So it's 2 and 2 get cancelled. 1 by 3 into a to the power 3 by 2 log of mod of a to the power 3 by 2 plus t. What is t? X to the power 3 by 2 by a to the power 3 by 2 minus x to the power 3 by 2 minus x to the power 3 by 2. Yeah, plus c. No, it's definite or indefinite, plus c. Make sure if it's indefinite, you're putting a plus c everywhere. Okay. So let's go to next question, 19th question. It's 1 by x into root of x minus 1 by x plus 1 into dx. Okay, so I'm just thinking secant theta, because 1 minus x, 1 plus x means cos theta, it's x minus 1, so dx is equal to secant theta, secant theta tan theta d theta. So substituting that here, 1 by secant theta into root of secant theta minus 1 by secant theta plus 1 into secant theta tan theta d theta. So it's 1 by secant theta into this will be 1 by cos theta. So when you write that, it will become 1 minus cos theta, and there will be 1 plus cos theta. Cos theta anyway gets cancelled denominator. This will be secant theta into tan theta into d theta. The secant theta get cancelled. This itself is tan theta by 2. We know 1 minus cos x is 2 sin square x by 2, 2 cos square x by 2. So tan theta by 2 into, you are left with a tan theta d theta. So after this, how do I solve? Because there are many ways to solve. So I'm just trying to think, is it definite? It's not. Okay. So then what do? Can I write it as sine theta by 2 by cos theta by 2, and can I write this as sine theta by cos theta, where I can write this sine theta as 2 sine theta by 2 cos theta by 2. So the cos theta by 2 cos theta by 2 get cancelled. So 2 sine square theta by 2 by cos theta, which itself is 1 minus cos theta by cos theta into d theta, and a 1 minus cos theta is secant theta minus secant theta d theta minus 1 into d theta. So secant integration of secant theta is log of mod of secant theta plus tan theta minus theta plus c, and whatever is theta stands for secant inverse of x, is it? Theta is secant inverse of x, and secant theta itself is x. So log of, what did I write here answer? Okay, I have written it. Okay, so then did I get it? Yeah. Substituting x, I get the answer. So log of mod of x plus root of x square minus 1 minus secant inverse of x plus c. Okay, so that's about it. Let's go to the next question. This is the 20th question. Is integration of sine of x minus a by sine of x plus a. So into dx, as soon as I see x plus a down, I'll write numerator as x plus a minus 2a by sine of x plus a into dx, where this is like sine a minus b. So sine x minus a, sine x plus a cos 2a minus cos x plus a sine 2a by sine x plus a here also, and a sine x plus a here also. This and this get cancelled, integration, this will become like this, and you have a dx here. So integration of, so then cos 2a is cos 2a into x. Cos 2a is constant, integration 1 dx is just x, minus this will be integration of cot of x plus a with the sin 2a common, minus sin 2a into common because it's constant, cos 2a into x minus sin 2a into integration of cot is log of mod of sine of x plus a. Is that the answer I've written here? Whatever written plus c, yeah, that's the answer I've written. Yeah, can you see x cos 2a minus sin 2a? So that completes till 20th question. So let's do the 21st also. Integration of sine to the power 6x plus cos to the integration of sine to the power 6x plus cos to the power 6x by sine square x into cos square x. Normally when I see 1 sine to the power 6x plus cos to the power, this is just straight away splitting it up. Just split the denominator, I mean split the numerator, and so things get cancelled. You can do it like that. But I'm just thinking sine to the power 6x plus cos to the power 6 is 1 minus 3 sine square x cos square x. So a sine square x into cos square x here, and a sine square x into cos square x here. Would that help? And just a thought. Okay, you can always split it up. You will get sine square and sine to the power 6 will get cancelled. You come sine to the power 4 and a cos square x down. But how about exploring sine to the power 6x plus cos to the power 6x is 1 minus 3 sine square x cos square x. So this will be like 1 by sine square x into cos square x, which itself is 1 by sine 2 theta, right? Sine 2x by 2 the whole square, which is 1 by sine 2x. So sine 2x is 2 sine x cos x, 2 is missing, so sine 2x by 2 the whole square. So this will become integration of cosecant 2x, which is 4 into log of mod of cosecant 2x minus cot 2x by 2. So this and this get cancelled. This is my thought for the first term. Okay, there's no log or anything on the right side though. Okay, what happens here is just sine square x cos square x get cancelled. So integration of 3 dx is 3x. So minus 3x, the integration of the right side. So I get it like this, and there's definitely a log, and this answer that I've written here does not even consist of any log. So that is my problem. So should I adopt this method? 1 minus, so no, do you know that 1 minus 3 1 minus 3 sin square x cos square x, sin to the power 4x plus cos to the power 4x is 1 minus 2 sin square x cos square x. Yeah. Okay, let me do an alter and see if I'm able to get the answer. Let me simply split it up. Okay, So if I just split it up, what happens? An alter, let me try. It will become sine to the power 4x by a cos square x, plus this will become cos to the power 4x by a sine square x dx. Okay, and you can write sine to the power 4x by this will become a sine to the power 4x. You can write it as sine cube x into sine x. No, I don't think there's any point in doing that. Okay, splitting it up doesn't help us much. Okay, let me figure out what is sine to the power 6x plus cos to the power 6x. It's like a cube plus b cube. And if I'm going to write a sine square x plus cos square x the whole cube is a plus b the whole cube, which is a cube plus 3a square b plus 3b square a plus b cube. So it is sine to the power 6x plus cos to the power 6x here plus 3 sine to the power 4x cos square x plus 3 cos to the power 4x sine square x. So this itself is anyway 1, and so 1 minus from this you can take a sine square x cos square x common, so you'll get a sine square x plus cos square x again. So 3 sine square x cos square x is what is sine to the power 6x plus cos to the power 6x, and that's what I wrote here, 1 minus 3 sine square x cos square x. Yeah, and I'm cancelling it and writing it as x. And this is sine 2 theta, sine 2 theta by 2 the whole square. Yeah, and it becomes a 4 sine square 2x, sorry. This becomes sine square 2x. Oh yeah, that was the mistake. Okay, understood. I hope you can correct it, guys. I'm sorry. So integration of from here it's wrong. Okay, from everything else is fine. So then it's integration of 1 by sine square 2x, which are 4 up there, which is integration of cos square which is integration cosecant square 2x. It's cot x, so minus 4 cot 2x by 2. Is this what I've written here? Minus 3x is fine, but a tan x minus cot x here. Sine square 2x, which goes up and becomes cosecant square 2x, cosecant square 2x, and integration differentiation of cot x is minus cosecant square x, so it will be with a minus sign also, and it will be cot 2x by 2, and there is a minus 3x. Why would this be tan x minus cot x? Okay, we know to solve this separately also. 1 by sine square x cos square x can also be solved as you can write a sine square x plus cos square x, that's easy. And now when you split it up, you get a secant square x plus a sine square get cancelled. Here cos square get cancelled, cosecant square x. So in that case you get a tan x minus cot x plus c in that method. So either way you get the answer. It's just that we have adopted a different way to do the sum, so you're ending up getting a different answer. That doesn't matter, both are the same. Okay, so let's go to next question. So let's go to 22nd question. Integration of 1 minus x the whole square by 1 plus x. Let me expand it. 1 plus x square minus 2x by 1 plus x square the whole square by 1 plus x square the whole square into e to the power x. So when you do that, this and the power get cancelled. If you assume this as f of x, this will become f dash of x, and so answer itself is power x into dx, e to the power x into, this is f of x, so e to the power x by 1 plus x square plus c. So that will become the answer for that sum. So let's go to next 23rd question. 23rd question is integration of x plus 3 into root of 3 minus 4x minus x square into dx. This is a supplementary syllabus. So when you have a root of something minus x square plus 4x minus 3, and let's do completion of square. So integration of x plus 3 into root of something minus x square plus 2 into 2x plus 4. Minus 4 means this become minus 7, so it will become plus root 7 the whole square into dx. So it's x plus 3 into root of root 7 the whole square. Okay, even before doing that, okay, I would like you to assume this is t, and okay, there's a special method to do the sum. Okay, because doing it this way, you see what happens is you get an x plus 2 the whole square minus x plus 2 the whole square, and you have an x plus 3 outside, so therefore you cannot right away do like this. So what should I do? The supplementary syllabus has a different approach to it. Okay, so what should we do is assume, you must memorize this. You have to write this as a into the x plus 3 can be written as a into differentiation of what is inside the root, which is minus 2x minus 4 plus b. So this is the format. Okay, a into differentiation of what is inside the root plus b is what is x plus 3, what is outside here. So then solving it, x plus 3 is equal to minus 2ax minus 4a plus b. So equating the xor coefficients, to minus 2a is equal to 1. So a is equal to minus 1 by 2. Minus 4a plus b is equal to 3. You know a is equal to minus 1 by 2. So 2 plus b is equal to 3 and b is equal to 1. So thus you get a and b. Once you know, instead of a and b, you can substitute this, and that itself needs to be written in the place of x plus 3. So a is minus 1 by 2 into minus 2x plus 4 plus b is just 1, and I have written it in the place of x plus 3, and the rest of the root can be copied as it is, x square minus into dx. So thus it becomes an integration of this whole thing in brackets, because in the place of x plus 3 we are writing this. So can you see I can bring it in like this? So it's minus 1 by 2 into minus 2x plus 4 into root of 3 minus 4x minus x square into dx plus a root of 3 minus 4x minus x square into dx. So both integrations separate. The advantage of this is you got a t and a dt here. Can you see this? This is t, this becomes dt. So it's minus 1 by 2 into root t into dt. So it becomes very easy, and here you can do completion of square as we normally do. Okay, so this is minus 1 by 2 into t to the power 3 by 2 by 3 by 2. And what is t? What did we assume as t? We have assumed this inside thing, what is in the root as t. So minus 1 by 2 into 3 minus 4x minus x square the whole to the power 3 by 2 by 3 by 2 is the first part's answer. Okay, yeah, and I take the 2 up, the 2 and 2 get cancelled, so I've almost got the first term's answer. Can you see? And this is a normal completion of square method, which you can proceed, I'm sure. The normal completion of square, and you can complete the sum. So let's go to next question. The 24th question is x into e to the power 2x by 1 plus 2x the whole square into dx. So the moment I see this, I assume 2x as t. I can't assume 1 plus 2x as t because e to the power 2x is there. 2 into dx becomes dt. So and dx becomes dt by 2, dt by 2, and x becomes t by 2 by 1 plus t the whole square. Hope I've written x is equal to x is t by 2, and this is 1 plus t the whole square. Yeah, and what about e to the power t? Yeah, so the sum has become like this. So what do I do now? You know, I can manipulate moment I see e to the power t. So I'll do t plus 1 minus 1 by 1 plus t the whole square by 1 plus t the whole square into dt. This and this get cancelled. This is f of x, this is f dash of x with an e to the power t here. So answer is e to the power t by 1 plus t 1 by 4. That's all. Whatever t is, so 1 by 4 into e to the power 2x by 1 plus 2x. 1 plus 2x. Where is the question? Oh, that was, where is the question? Yeah, 1 plus 2x plus c. We got the answer. Okay, so then That's about the 24th question. So let's go to 25th. 25th question is 1 by 1 plus e to the power sin x into dx, which is from minus pi by 2 to pi by 2. So this is, if you put f of minus x, it is turning minus f of x, so it's not that property, it's not going to help me in any way. So f of x can be written as f of a minus x dx. So using that, no, a plus b minus x, I think. Yeah, in this, as soon as you see this, you should know you're going to use the property a to b f of x dx is f of a plus b minus x into dx from a to b. Because when I do that, it becomes minus pi by 2 to pi by 2. Okay. 1 plus 1 e to the power minus sin x it will become. So if I am going to consider it like this, if I take LCM, if I am going to solve this, it's like minus pi by 2 to pi by 2 e to the power sin x by e to the power sin x plus 1. The advantage of assuming like this is this is also I and this is also I, and when I do at 2I, the numerators get add 1 plus e to the power sin x, 1 plus e to the power sin x by 1 plus e to the power sin x. So 2I is equal to integration of 1 dx minus pi by 2 to pi by 2. It becomes so easy to solve the sum. So it's x from minus pi by 2 to pi by 2. So 2I is equal to pi by 2 plus pi by 2. 2I is equal to 2 pi by 2. And so I is equal to pi by 2 is the answer. Is that answer? Yeah, so that's about it. So let's go to 26th question. Minus a to a, root of a minus x by a plus x into dx. As soon as I see this question, I know I can substitute x as a cos theta, which is convenient for me. So dx will be minus a sin theta d theta. And substituting here minus a to a, root of a minus a cos theta by a plus a cos theta into dx minus a sin theta d theta. So this a can be cancelled throughout, and it will become 1 minus cos theta by 1 plus cos theta, which itself is tan theta by 2, as you know. Minus a into the sin theta can be written as 2 sin theta by 2 cos theta by 2 into d theta, and this tan theta by 2 now can be written as sin theta by 2 by cos theta by 2. The advantages get cancelled and you have an into here. So then a minus a can be taken out common, minus a to a, 2 sin square theta by 2, 2 sin square theta by 2 into d theta. So when you do this, it's minus a out, minus a to plus a, 1 minus cos theta, 1 minus cos theta and d theta, 1 minus cos theta is 2 sin square theta by 2. So then this itself is theta minus integration of cos theta sin theta. Okay, what about the limits? The limits do change when I substitute x as minus a. I'm always coming to that at last. I should do it then and there. But anyway, if it's minus a, cos theta becomes minus a, cos theta becomes minus 1. So it will be pi. And it's a, it's 1, so 0, 0 to pi. Okay, so it's pi to 0. It's pi to 0. But while integrating, when I have 0 to pi, I can always change around the symbol and write 0 to pi, you know. So then integration of 1 minus cos theta 0 to pi, because I have taken out the negative sign, so it's into d theta. So this will become, can I write it as 2 times 0 to pi by 2? Because f of 2a minus x is not the same as f of x. No, I can't do that. So I cannot use the property. I just have to theta minus sin theta 0 to pi. So if I substitute upper limit, a pi is the answer. Oh, that's the answer. Okay. So let's go to 27th question. So 27th question is integration of minus 1 to 1 x cube plus mod x plus 1 by x square plus 2 mod x plus 1. We did a similar sum, but that was an x there. Here it's x cube. It doesn't matter even if I split this up as two different terms, x cube by x square plus 2 mod x plus 1 plus mod x plus 1 by x square plus 2 mod x plus 1. I can do that. This itself is 0 even if it's x cube, and I can proceed the sum as I did previously. Okay, so let's go to the next question. 28th question. Minus pi to pi cos ax minus sin bx the whole square into dx. So this is like what about property? Is f of minus x? No, I have to split this up to use the property. I can't use the property now. cos square ax plus a sin square bx minus 2 cos ax sin bx integrated from minus pi to pi, minus pi to pi, dx everywhere. And when you do this, f of minus x is plus f of x, so 2 times 0 to pi cos square ax. Similarly here squared, power is squared, so f of minus x will be f of 2a minus x will be f of 2a minus x will be f of x. So in this case, so you can write 2 times 0 to pi, 2 times 0 to pi sin square bx, whereas this will become 0 because f of 2a minus x here is minus of f of x, because sin of minus x is minus sin x, so this is a cos and sin multiplied. So now you can again apply property because it's even integral, so 2 times 0 to pi by 2, so there's a 2 out, so this becomes 4 times 0 to pi by 2 cos square ax plus a 4 times 0 to pi by 2 sin square bx dx. Okay, then you know how to integrate a cos square ax is 1 plus cos 2ax by 2 and to dx, integrate from 0 to pi by 2 plus 4 into 1 minus cos 2bx by 2, integration of this, integrate from 0 to pi by 2 dx, and the rest is a known story. You can integrate and check your answers. Okay, so let's go to next question. So you will, can you see, you'll get a pi by 2 here and you'll get a pi by 2 here with a 4 of course. So it will be 8 pi by 2 and you'll get a 4 pi, and can you see where is the answer for this sum? Yeah, you have a 2 pi, okay. You already have a 2 also, this 2 can be taken out, and so you're getting the answer, can you see? Yeah, so let's go to 29th question. 29th question is 29th question is minus 2 to 2 mod of x cos pi x dx. I told you in this when we did a textbook sum, we did it mod of x cos x sin pi x, where from minus 1 to plus 1 it's positive, and 1 to 3 by 2 it was negative. And while doing so I also told you how to do it for x cos pi x. It will be like normally it's minus 1, minus half, 0, half, 1, 3 by 2, and then it will be 2, then it will be, oh, that's all. No, for this we'll take any one example, say such as 1 plus 1 by 2 by 2, 1 by 2 by 2 is 1 by 4. Yeah, we know this is 1 by 4. You can substitute this in this and check if it's positive or negative. 1 by 4 into cos pi by 4, it's positive. Can you see, it's definitely positive. So the fact that this is positive here shows that it will be negative, it will be, we know that. You give examples and see. Okay, so but here if you give an example, 1 plus 3 by 2 is 5 by 2, it will become 5 by 4. You give one example, 5 by 4 into cos 5 pi by 4, it's cos pi plus pi by 4. In the third quadrant it's negative, so this is negative. Like this you should give examples and see. And so what happens between 3 by 2 and 2, it's 3 by 2 plus 2 by 2, so it's 5 by 4. No, what is it? 3 by 2 plus 2, 1 plus 3 by 2 by 2, okay, this is 7 by 4, 7 by 4. Give that as an example, 7 by 4 into cos 7 pi by 4, 7 by 4 into cos, what should I write it as, 2 pi plus minus pi by 4, 2 pi minus means fourth quadrant, cos is positive, so you know this is positive. Like this you have to give examples, but the question is not from minus 1 or anything, which I just gave you some examples. If it is so, you just have to substitute them and find out whether it's positives or negatives. The question is only from, the question is from minus 2 to 2. Oh, the question goes from minus 2 to 2, but I can do 0 to 2. Why? Because if I put f of minus x It's turning out to be f of x. So I can write minus a to a f of x dx as 2 times 0 to a f of x dx. I can use that property because cos of minus x is cos, and there's a mod, totally there's a mod, so I'm allowed to do that. Okay, so then therefore if I write it as, otherwise the sum will be such a huge sum. So predictably it's 2 times 0 to 2. Yeah, and it's but you can't write a 0 to 2. The 0 to 2 has to be split it up. So in integral 0 to 2 mod of x cos pi x dx, and you know 0 to half it's positive, half to 3 by 2 it's negative, 3 by 2 to 2 it's positive. So you should substitute 2 common, 0 to 1 by 2 and x cos pi x plus dx plus 1 by 2 to 3 by 2 is minus x cos pi x plus 3 by 2 to 2 and x cos pi x. So you have to do integration by parts, the same answer for everything, but the limits change, so you have to substitute slowly, check out if you are getting the answer. So it's a very important sum, both x sin pi x and mod of x sin pi x and mod of x cos pi x is very important. Okay, and so then let's go to 30th question. Please do it slowly and check out your answers. Minus pi by 4 and a pi by 4 log of sin x plus cos x into dx. Minus pi by 4. Okay, what about f of minus x? What happens to that? The sin of minus x is minus sin x. So to become log of cos x minus sin x, is it? I'm just doing, okay. So I can't do anything with it, with that property f minus a to a. So I'm just thinking, can I do a plus b minus x? So is this like a to b f of x dx can be written as a to b f of a plus b minus x into dx. Can I do that? In that case it will become sin of minus x, so it will become log of cos x minus sin x dx, and this is minus pi by 4 to pi by 4. So then now I can consider this as I and this as I. So, and if I do a 2i, a log and log will get added and it will become multiplication. So log of cos x plus sin x into log cos x minus x is cos square x minus sin square x, which is cos 2x formula. So then therefore it's integration of log of cos 2x dx. The question becomes like this, and this is 2i, and it's still minus pi by 4 to pi by 4 only. Okay, I've not used now can I use f of minus x? F of minus x is f of x, so I can write 2 times 0 to pi by 4 because cos of minus theta is cos theta, so I can write it as 2 times 0 to pi by 4 log of cos 2x dx. The advantages 2 and 2 get cancelled. So now the question becomes simple, log cos 2x, log cos 2x. You can write as log cos 2x into 1 and do integration by parts. 0 to pi by 4 log cos 2x into 1 dx. So when I do integration by parts, a log of cos 2x into x minus big integration 1 by cos 2x into minus sin 2x into 2. So differentiation of this sin 2x, which is cot 2x, right? So, no, tan 2x, which itself is tan 2x. No, we can keep it as sin 2x by cos 2x. And an integration of this second term is just x, yeah, into dx. So this will become I is equal to x log cos 2x plus a 2 into x tan 2x. I'll eat algebra after that trigonometry. So I is equal to x log cos 2x. Have I got at least the first part correct? Is it it's yeah, it's definite, right? So when I substitute 0 to pi by 4 in this, let's see if I'm getting the first part correct. So it's pi by 4 into cos 0. Okay, it's going to become cos 0, and so it's going to be upper limit is 0, lower limit is also 0. Okay, so then this entire answer is becoming 0 first term. So maybe the question is going to boil down to this. So 2 into integration by parts, x into integration of tan 2x is minus log of cos 2x by 2 minus big integration, x differentiation is 1 minus log of cos 2x by 2 into dx. So can you see that this itself is like when I take the 2 inside, I am allowed to take the 2 inside, it will become minus 2 and 2 get cancelled, minus x log cos 2x. And take the 2 inside, it will become integration of take the 2x log cos 2x into dx. It cannot be with a positive sign. There's something seriously wrong with the question. Let me try to do the sum again. Let me try to think of what I've done. Minus big integration, differentiation of 1 by cos 2x into minus sin 2x, so it becomes a plus. Yeah, so it becomes tan 2x. Now I've got to again integrate it. So it's there will be a minus sign here. There will be a minus sign here. Minus log of cos 2x or log of secant x I can use. So plus log of secant 2x by 2 plus log of, let me try that, let me see if I'm getting the answer that way, like log of secant 2x by 2 into dx. So which will make it that case, okay, there will be in that case there will be a negative sign in this. Yeah, there will be a negative sign. So if I'm going to convert into, okay, so this is with an x log secant 2x minus log of secant 2x by 2, it will become plus 1 by 2 by 2. No, I'm not getting the answer. Something is seriously wrong. Let me try the sum once again. Everything else is fine till here, until I was doing this. Let's check log of sin x plus cos x. I'm just doing a plus b minus x in this. How do I know? Because no point in checking f of minus x is equal to minus f of x. That is also not happening. F of minus is equal to f of x is also not happening. So I can't write 2 times root to pi by 4 immediately. So I'm using this property when I get cos of minus pi by 4 plus pi by 4 minus x. Cos of minus x is cos x, whereas sine will become minus sin x. So this also I, that's also I, 2i is equal to cos square x minus sin square x log of, which is log cos 2x. Still here it's fine. Now here when I apply f of minus x, it's becoming f of x. And so 2 times 0 to pi by 4 and 2 and 2 thus get cancelled. 0 to pi by 4 log cos 2x dx. And this is where I made a mistake. You are not supposed to do direct integration like this. Okay, I've shown you doing a mistake. Please, I'm not allowed to directly integrate like this. Let me assume 2x as t, because we have done a similar sum, which is a textbook sum, wherein we have a log sin 2x dx, where we took 2x as t. Therefore, so important that you take a cos 2x. Okay, so then the whole thing turned out to be wrong. You have to take 2x as t, 2 into dx is equal to dt. That's what makes this sum very, very important. The limits is also going to change. So it's 0 to pi by 4 means it becomes pi by 2 log of cos t into dt by 2. So the question becomes like this. And so then when you apply property a minus x, f of x can be written as f of a minus x, this will become log sin t into dt 0 to pi by 2. This itself is a textbook sum whose answer is minus pi by 2 log 2. So it's minus pi by 4 log 2 is that answer. We won't get the answer if you do directly integration by parts. That's the biggest mistake I was doing there. You get that? Okay, so I'm keeping the mistake as it is so that you will know that you got to correct it like how I corrected. Okay, so that completes the 30 questions in there. And if I can finish the 31st, then it's only the differential equation sums that is left off. So let's do the 31st question. 0 to 2 pi x sine to the power 2n x by sine to the power 2n x plus cos to the power 2n x dx. And whenever you see this is I, and you see an x here, you can put a 2 pi minus x into sine to the power 2n into 2 pi minus x is anyway x, and sine to the power 2n into 2 pi minus x is the same. Everywhere is the same because it's even integrals, powers are even integrals. And so then if you add these two, it will become 2i, and x will get eliminated. You will have 2 pi into sine to the power 2nx by sine to the power 2nx plus cos to the power 2nx. When you do 2i, the x and x components get cancelled. So the 2 and 2 get cancelled. You have I is equal to pi into, it is 0 to 2 pi, and can I write it as 2 times 0 to pi using the property f of 2a minus x is equal to f of x? Yes. So 2 times 0 to pi sine to the power 2nx. You must write the property in exam, 2nx plus cos to the power 2nx, using f of 2a minus x is equal to f of x. So then therefore 0 to 2a can be written as 2 times 0 to a f of x dx. So then I is equal to pi into, can I again do f of 2a minus x? Once again applying that, it will become 2 times, so 4 times 0 to pi by 2 sine to the power 2nx by sine to the power 2nx plus cos to the power 2nx. Now this is 4 pi. Now applying again f of x can be written as f of a minus x into dx. So I am trying to do that, become cos to the power 2nx by cos to the power 2nx plus sine to the power 2nx. So the denominator remains the same, so you can add these two up. So 2i is equal to 4 pi into integration of 1 dx is 0 to pi by 2. So this and this get cancelled. I is equal to 2 pi into x 0 to pi by 2, and 2 pi into pi by 2 will become just pi square, and is that answer? Yeah, so that's about it. Certain sums I did it till the end, certain sums which involves a lot of calculations I've left it for you to do it. If you don't get the answer, you tell me. I'll send the children who have completed it can send the pictures of those questions to others, and or I'll send you the pictures of the entire sum. So I'm sure I've done all integration sums, only a few of differential equation sums in the question paper I've not done. Okay.